you can directly apply.
Good morning to all.
Good morning, sir. Sir, there seems to be a mistake in the answer key of the part test. In the 18th question, where I had sent you that beads are there and it's going in circular motion around the circular track.
I forwarded that to the paper setter yesterday itself. I think somebody sent, you sent. I forwarded it to the paper setter. Let us see. Yesterday, none of them were working. Today, he'll get back.
Okay, sir.
No, this week, do we have a doubt lecture?
No, sir.
This week, we don't have a doubt lecture.
No, sir.
Okay, then this
So you
week.
can keep on Thursday if possible. We have only college.
Thursday. Thursday, your college timing is?
We don't attend it. In general.
It's still 140.
Pardon, up to?
140.
That will be the same across all the centers?
Probably. Mostly.
No, sir. In the other, it's mostly till 12:40, 12:30.
Okay. Do we have a second lecture this week?
Tomorrow.
Tomorrow.
So tomorrow's lecture will convert it into a doubt lecture. Tomorrow's lecture will be a doubt lecture. Tomorrow, what time is the lecture?
So at the same time.
Harbinja says Thursday we have got practicals. Practicals, kahan pe?
Sir, practical we have got today.
Practicals we have?
Sir, for
From
Andheri.
2 to 3.
You people are going to the campus.
No,
No,
sir.
sir.
Online
online.
practicals. Online.
Sir, but we are going to be
Virtual
there just for
practicals.
sake, not attending it.
Attend, yeah, attend. Okay, no. Tomorrow's lecture I'll convert it into a doubt lecture.
So SHMT, what exercise will you discuss?
जितना होगा उतना करेंगे यार, अब हर चीज का माप तो थोड़ी होता है. No. What was the last thing we taught in the previous class?
Semi-infinite wire.
Field due to a wire, right?
Yes, sir.
Infinite wire, semi-infinite wire done.
Yes, sir.
Yes, sir.
Okay, semicircular wire.
No, sir. So we did a circular ring.
Semicircular wire. We are interested in field due to this ring at the center. Lambda is the mass per unit length. Mass per unit length. Consider an element at an angle theta such that this will be r d theta. How do you get the field force experienced by a unit mass? Force experienced by a unit mass. If I keep a unit mass here, it will be attracted by this. If I keep a unit mass here, it will be attracted by this. So dE will be in this direction. This will have a dE cos theta and this will have a dE sin. Do you all agree with this?
Yes, sir.
Can I claim that all dE cos theta components will get cancelled out?
Yes, sir.
Because for every element here, there will be an element here which will give me an identical dE and the vertical components will cancel. Integral dE sin theta. Integral dE sin theta. Remember, vectors will not be integrated directly. You will not integrate dE directly. You will integrate dE cos theta or sin theta only when you know that the vectors are in the same direction. Right? G dm by r square sin theta. G dm by r square. G lambda r d theta by r square sin theta. Agreed. Dm is lambda r d theta. Lambda is mass per unit length. R d theta will be the length of that element. G lambda by r integral sin theta d theta 0 to pi. Least value of theta is 0, maximum value of theta is pi. Least value of theta is 0, maximum value of theta is pi. Right? Can you complete the problem?
Yes, sir.
Tell me what is the final answer you people are getting.
G lambda by r.
Okay. This will turn out to be 2g lambda by r.
So this is a net gravitational force, right?
Right. At the center of the semicircular ring, net gravitational field.
Field.
If I keep a mass there, that mass into this field is the force on it. If I keep a mass there, that mass into this field is the force on it, right?
Yes, sir.
Can I rub the board?
Yes,
Sir,
sir.
can you just tell that when there was an entire ring and a mass was placed at a distance of x, that problem? I'm getting some confusion in it.
SHM.
So just before this one in last class, we had done that. Find the net force.
Field due to a ring.
Yes, sir.
Do you know the potential due to the ring? Potential due to the ring along the axis.
GM.
Minus. Right?
Yes, sir.
Field will be minus dv by dx. Move along this length by a distance of dx. Potential difference divided by the distance is the field. Differentiate this with respect to x.
Got it, sir. Thank you.
Now, this is a semi-infinite wire, this is a semi-infinite wire, this is a semicircular wire. All throughout of lambda mass per unit length. Mass per unit length. Find the field at O. Find field at O. Semi-infinite wire, semicircular wire, and semi-infinite wire. Find the field at O. Do you people remember the formula for
Zero, sir. Zero.
semi-infinite wire? It will be G lambda by R and G lambda by R. Yes or no?
Yes, sir.
Yes, sir.
Now watch out for this. Because of this, it will be G lambda by R and G lambda by R. Because of this semi-infinite wire, I showed the field. Because of this, it will be G lambda by R and 2 times. Because of the semicircular wire, you just now derived this as 2G lambda by R.
So answer is 0.
Right. So the answer will be 0. Can I rub the board?
Yes, sir.
Yes, sir.
If you have a ring which is fixed, the ring is fixed. It is of mass capital M. Along the x-axis, I have a mass small m placed here. Find force on small m due to the ring. What would I do?
So we did this.
Force is m into field. This m field because of the ring will be gmx upon r square plus x square to the power 3 by 2. This will be the force on the point charge. All of you agree with that?
Yes, sir.
Now, instead of a point charge, we'll make it semi-infinite wire. Instead of a point charge, we'll make it semi-infinite wire. I need the board.
Sir, why did you do GM into X?
What is the expression for the field due to the ring?
GM by R square.
रिंग का फील्ड देख के बोलो जरा, नोट्स देख के बोलो. You are not supposed to go wrong with it.
So it is given this only. GMX by R square plus X square is to 3 by 2.
Right? That into small m will be the force on small m.
Yes, sir.
Done, sir.
Now what they have done to this problem is they placed a semi-infinite wire. Semi-infinite wire of lambda. Find the force on the semi-infinite wire due to the ring. Find force on semi-infinite wire due to ring. Will you try or should I discuss?
So we'll try.
One way of solving this traditionally will be.
So one minute, please.
Sir, what is the answer?
I think G capital M lambda by R.
Yes, sir.
Consider a small element dx at a distance of x. df will be gm by x square. Sorry. df will be dm into e gmx upon r square plus x square to the power 3 by 2. gmx upon r square plus x square to the power 3 by 2. This is the field due to the ring. What will dm be? Lambda dx gmx upon r square plus x square to the power 3 by 2. df will be inverse. Integral df is gm lambda integral x dx upon r square plus x square to the power 3 by 2. Least value of x is 0, maximum value of x is infinity. This integral is a standard integral which you have done n number of times. One way is to take x is r tan theta, the other way is let t square be equal to r square plus x square. 2t dt is 2x dx. So x dx I will put as t dt. Denominator will become
TQ.
t cube. Integral t to the power minus 2 dt is minus 1 by t. T is root over of r square plus x square. G capital M lambda minus 1 by root over of r square plus x square 0 to infinity in the place of x. And you get the answer. This is one traditional way of solving the problem.
Sir, I did it in different way. Can you please
One
confirm?
second. Wait. Complete.
So while substituting, I carried a negative sign with the electric field. That's just for direction, right? So
Yeah.
the answer, will there be an extra
The
negative?
final negative sign tells me that the force is towards the left.
Okay, sir. Thank you.
So lambda gm by r, right?
Gm lambda by r.
Done, sir.
Now the other way of looking at this is every action is an equal and opposite reaction. You are asking me to find out the force on the semi-infinite wire due to the ring. Do the reverse. Due to the semi-infinite wire, find out the force on the ring. It becomes much easier. This is the semi-infinite wire. Semi-infinite wires. Here field will be inwards this way and inwards this way. This will be G lambda by R, G lambda by R. This is the semi-infinite. Can I claim that this into dm, this into dm, this into dm, this into dm? G lambda by R is the field due to the semi-infinite wire. G lambda by R is the field due to the semi-infinite wire. Right? So this G lambda by R into dm will be this component, and this G lambda by R into dm will be this component. Can I claim that all this G lambda by R into dm will get cancelled out? All of this will get cancelled out. I am left with this. Integral dm will be mass of the ring. Integral of this will be G lambda capital M by R. Why are you not taking this? That will get cancelled out. You have found out the force on the ring due to the infinite long wire. Can I have the board?
Yes, sir.
No, the most important part of gravitation. This is called Shell theorem. Its application will be enormous in electrostatics. The result is something which will change the dynamics of physics. This is field and potential due to a hollow sphere. Now at the end of the game, you people will have to explain one answer to me. I have calculated field and potential for a ring. I am going to calculate field and potential due to a hollow sphere. I'll calculate field and potential due to a solid sphere. But for an infinite and a semi-infinite wire, I'm calculating only field. I didn't calculate the potential, if you people observe. After I finish solid sphere, keep this in your subconscious mind and keep reasoning why we didn't calculate the potential. There's a reason for it, right? Hollow sphere. After field and potential due to a hollow sphere, will come back to SHM and we'll deal with application of SHM in gravitation. Right? Now, this result of hollow sphere will continue with us all throughout in electrodynamics. So remember this result. This is the only time when I will do it traditionally using calculus. In electrostatics, we'll derive it using a new mathematical tool called Gauss.
What's that?
And doing it traditionally.
So what is it called?
Shell theorem.
No, sir, the tool which you're talking about, new tool.
तब पढ़ाऊंगा अभी क्यों चिंता है यार. Now, what are you interested in? At a distance of r, I want the potential. First, always I'll start with potential because potential is a scalar. This is theta, this is r d theta. I considered an elemental ring. What is the radius of this ring? What is the radius of this ring?
R.
Sin theta.
R sin theta.
R sin theta. What will this distance be?
R cos theta.
R cos theta. You will take small r to be the distance of that point from the center at which I want the potential. You will take small r to be the distance of that point from the center at which you want to calculate the potential. Now, because of the ring, can you tell me what is the expression for potential? Minus g dm by root over of this square plus this square. Root over of r sin theta whole square plus r minus r cos theta whole square. Do you all agree with this?
Yes, sir.
Potential due to a ring along its axis is minus gm by root over of r square plus x. Right? Minus g dm. dm mass per unit surface area 4 pi r square. Mass per unit surface area into surface area of the ring 2 pi r sin theta into rd. 2 pi r sin theta into rd upon root over of r square plus small r square 2 small r capital R cos theta. So far, so good. Yes or no?
Yes, sir.
Sir, 1 minute.
Mass per unit surface area into surface area of the ring. 2 pi into radius of the ring. R sin theta into thickness of the ring is Rd. 2 pi r square, this will go minus gm by 2. This will be sine theta d theta upon root over of r square plus r square. So far, so good. Yes or no?
Yes, sir.
Now, let z square be equal to r square plus r square. See, this is z hypotenuse. So, this square plus this square is technically z. 2 small r, capital R cos theta. This will be r sin theta and this Pythagoras theorem. Z square is equal to this plus this square. 2z dz is 2 small r, capital R sin theta d. Differentiation of cos theta is minus sin theta, so this becomes plus. Right? 2 gets cancelled out. Sin theta d theta will be z dz by small r capital. dv is minus gm by 2. Integral of sin theta d theta is z dz by small r capital R divided by this value will be equal to z.
Yes, sir.
Sin theta d theta is substituted, this z will get cancelled out. dv is minus gm by 2 small r capital R integral dz.
Yeah.
Integral dz will be z, but I should decide the limits before I write the next step. What is the least value of z? As I consider the ring here, the least value of z will be the ring
R
I
minus
consider
R.
here. Small r minus capital R. The ring which I consider here will have maximum value of z. It will be small r plus capital R. The ring that I considered, if I move to the right extreme, this distance will be small r minus capital R. If I move to the left extreme, it is small r plus capital R. This will be minus gm by 2 small r capital R. Integral dz is z. It will be r plus r minus r plus capital R. What is the next step that you get? I'm running short of space. Can you write the next step?
Yes, sir.
Minus gm by small r. The next step is minus gm by small r. Are you trying to tell me for any external point, potential of the sphere will behave in such a way such that the whole of the mass appears to be concentrated at the center? After doing whole of the derivation, we realize that if I would have kept the whole of the mass of the sphere at the center, whatever potential you get, you will get the same potential for a hollow sphere. I repeat this statement, listen carefully. For an external point, as far as a hollow sphere is concerned, whole of the mass appears to be concentrated at the center. For an external point, whole of the mass appears to be concentrated at the center. For field also, will it be the same? Differentiate potential with respect to R and C. You will get field is Gm by R square. Differentiate potential with respect to R. You will get field is Gm by R square. So for any external point for a hollow sphere, whole of the mass appears to be concentrated at its center.
So yeah, m is the mass of the shell, right?
Mass of the shell. Perfect. That's why you took mass per unit surface area जब लिया है, m divided by 4 pi r square लिया है.
So the point you have taken is unit mass, right? at distance x?
फिर से बोलो.
जो point लिया at a distance of r, that is point unit mass, right?
The point where I'm finding out the potential.
Oh, sorry, sir, my bad.
That is the point at which I'm finding out the potential.
Done, sir.
Now listen. Can I rub the board?
Yes, sir.
Yes, sir.
Now the results that I summarize here on the board are very, very, very important. For the hollow sphere, at a distance of small r, what it tell me? Potential was Gm by r. What will the field be? Minus dV by dr. Differentiate this with the negative sign, you will get Gm by r. Field will be inwards towards the center. Field will be inwards towards the center. In gravitation, I never have a doubt with the field because it is the only force of attraction. On the surface, potential is minus Gm by capital R. I am just substituting small r with capital R. Field is Gm by R square. Now the most important thing, the shell theorem. Potential inside will be minus Gm by capital R, which will be a constant. Potential anywhere inside will be the potential on the surface of the shell. Whatever is the potential on the surface of the shell, everywhere inside potential will be the same. If potential is constant, field will be 0. Now, how did you get that potential is constant? Now go back to the previous page where you have derived dv. Integral dv minus gm by 2 small r capital R integral dz. This was what you have done. Yes or no?
Yes, sir.
Minus gm by 2 small r capital R z. Now limits of z, same derivation, same variables, only thing my limits have changed. Now this is the point, small r, or I'll draw it here. This is the point, small r. This is the point where I want the potential inside the shell. Now when I consider the ring here, what will this distance be? Capital R minus small r. When I consider the ring here, what will this distance be? Capital R plus small r. So now your limits will be capital R minus small r to capital R plus small. Your limits will be capital R minus small r to capital R plus small r. See what you get. Gm by 2 small r capital R plus r minus r plus small r minus Gm by capital R. Whatever is the potential on the surface, everywhere inside potential will be the same. Whatever is the potential on the surface, everywhere inside potential will be the same. If potential is constant, field inside is 0. If potential is constant, field inside is 0. So shell theorem में field inside a hollow spherical shell is always 0. Field inside a hollow spherical shell is always 0.
So how are you directly claimed it that inside is the same potential everywhere?
ये क्या है?
Before that you had directly said no. So that I'm
Because I know the result I wrote. I didn't directly say.
Oh, okay, sir.
Excuse me, sir.
Yeah.
Sir, inside the hollow sphere, we're trying to find the distance of the elemental ring from the center, right? That's how we're taking the limits.
No. What did you take Z as? When you took outside, this was Z, right? This was Z. So distance of the element from the point at which you are finding out the potential. Least value of Z was small r minus capital R. Maximum value of Z is small r plus capital. So distance of the ring from the point at which you are finding out the potential. Distance of that point from the ring at which you are finding out the potential. So it will be capital R minus small r in this.
Yes, sir.
Field inside a hollow spherical shell is
0.
field inside a hollow spherical shell is
Minus GM by capital R.
yes, field
0.
0. Field inside a hollow spherical shell is
0.
0. Do not forget that. Even by chance, you are not supposed to go wrong. It is extensively used all throughout in electrostatics. Can I rub the board?
Yes, sir.
Now, if it were a solid sphere, firstly, I need the potential at an external point. Consider a hollow spherical shell of radius x and thickness dx. dV is minus gm by r. Why? Whole of the mass of the shell will appear to be concentrated at its center for an external point. Agreed? Whole of the mass of the shell will appear to be at the center for an external point. Integral dV is minus g integral dm by r. V is minus gm by r. That means even for a solid sphere at an external point, whole of the mass appears to be concentrated at the center. This will be gm by r square. On the surface of the sphere, potential is minus gm by capital R. Field is gm by r. Potential for an external point, whole of the mass appears to be concentrated at center. Field for an external point, whole of the mass appears to be concentrated at the center. On the surface, you are replacing small r with capital R. Inside, the dynamics will change. Take it down till here, I'll derive even inside.
Sir, I have a doubt that shouldn't the field at the surface be equal to 0 because R will be constant, right? Just as we did in the previous thing inside.
Now listen, all of you. Did you people understand his doubt? Now the boy's doubt is here and here and here and here potential is constant. Am I right?
Yes, sir.
In this direction, field is 0 along the tangential direction. Nothing wrong with it. Along the tangential direction, field is 0. Along the radial direction, it's not 0 because just inside and just outside, along the radial direction, field changes. Suppose I take inside at these 2 points, here field will be 0, while potential here and potential here is the same. But when you come to the surface, just inside, just outside, potentials are not the same.
Understood, sir.
Outside, I will move by a small distance, dx, I'll have a potential difference. You tell me on the surface, potential is the same. Along tangential direction, field is 0. Recollect the partial differentiation that we learned. Differentiation of potential with respect to x, with respect to y, with respect to z. जिस direction में field चाहिए, you will find out potential difference only in that direction.
So on the surface, it's like we are walking on the surface, so it will be field will be 0.
Yeah, along the tangential direction, field will be 0.
And so just inside it is like same as on the surface, but outside it's
Along
different.
the radial direction, field is not 0. There are 2 directions, radial and tangential. Along the tangential direction, potential is constant, hence the field is 0. Can I rub the board?
Yes.
So here capital R is radius and small r is distance from the center, right?
Capital R is the radius.
Okay, sir.
Small r is the distance of that point from the center. Capital R is the radius. Small r is the distance of that point from the center at which you are finding out the potential.
So why can't we consider whole mass to be concentrated at the center for other bodies as well, at the center of mass?
You don't get that, right? Now for a hollow sphere, you derived it, you're getting the answer.
Okay, sir.
this
So it's
applies
by
only.
derivation.
Yeah, in the derivation, if we get, we accept that whole of the mass appears to be concentrated. Now I took a ring. It doesn't appear that way. It will be dependent on x.
Okay, sir.
Now, the leftover part in this is field and potential inside a hollow sphere. I mean solid sphere. Field and potential inside a solid sphere. inside a solid sphere, when you consider field and potential, first of all, we'll deal with field. This I will take as small r, radius of the sphere is capital R. Now I am interested in the field at a distance of small r. This is M1 and this is M2. Field at a distance of small r will be field because of M1 plus field because of M2. M is equal to M1 plus M2. Do you all agree with this? Say something.
Yes, sir.
Yes, sir.
The vectors, right? Like,
Field is a vector. But look at the advantage of solving it this way. Field here because of M1. Because of M1 and finding out field on the surface of the M1, it will be Gm1 by small r. On the surface of any sphere, you told me it is Gm by r square. Because of M1, on its surface, it will be Gm1 by r square. Are you convinced?
yes, sir.
Because of M2, it will be 0. Because M2 I can consider to be thin shells. Each shell will give me 0 inside. Add up all the zeros, what do I get? Everybody should be convinced with this two logics.
So you're talking on the surface of M1, right?
Right? On the surface of M1, I want the field. Due to M1, it is Gm1 by r squared. Due to M2, it will be 0.
Yes, sir.
Because M2 I will assume is constituting thin shells. Each shell will give me 0 field inside. Adding up all the zeros from small r to capital R will give me a 0. This point, is it clear to all?
Yes, sir.
G mass per unit volume 4 by 3 pi r cube into 4 by 3 pi small r cube by r. Mass per unit volume into volume of M1. So 4 by 3 pi, 4 by 3 pi will go Gm small r by r cube is the field inside a solid sphere. Quite a few times they prefer to write this in terms of density. G density into 4 by 3 pi r cube upon r cube into r 4 by 3 pi rho g smaller. This is one way of writing, this is one way of writing, but one thing is for sure. For a solid sphere, field ka graph if you draw field as a function of r, till I come to the surface, field is directly proportional to the distance. Field is directly proportional to the distance. Outside the surface, field is inversely proportional to r. Field inside the solid sphere is directly proportional to r. Outside the solid sphere, it is inversely proportional to r square.
Sir, I'm trouble having understanding that what is the scene going over here. Is it like a full solid sphere or it's like two shells inside or what is happening that way?
Shell कहाँ लोगे कैसा लोगे क्या लोगे shell में?
So what is
shell के
M1 and M2?
अंदर मास कैसे assume करूंगा मैं? shell के अंदर M1 M2 मास कैसे assume करूं?
So you are considering a thin shell inside a sphere of mass M1?
This is a solid sphere.
Yes, sir.
I want field at a distance of small r.
Yes, sir.
So it should be field because of a solid sphere of mass m1 and field because of a hollow sphere of mass m2.
So, but what about the mass inside M1? There will also be a small sphere left inside M1, right? Won't that be creating a field?
m1 के वजह से on its surface will be g m1 by r square.
Understood, sir. Understood.
m2 के वजह से I assumed thin shells. Each shell will give me 0 inside. Adding all the zeros, it turned out to be 0.
Got it, sir. So, sir, this we calculated field at a distance of r from center, right?
Yes. We found out the field on this surface. We found out the field on this surface at a distance of r from the center.
So,
Ah,
so the field inside M1 should be 0, right?
right.
Sorry, sir.
M1 is a solid sphere. M1 is not a hollow sphere.
So can you repeat?
M1 is not a hollow sphere. It's a solid sphere.
So, so for M2, like you took the additions of 0, so the final thing came 0. Like that, won't it happen for M1 also because both are solid, right?
M1 का अगर आपने शेल एज्यूम किया है, आप फील्ड कहां
Yes,
पर
sir.
कैलकुलेट कर रहे हो उसके वजह से?
So, वो surface पे.
सरफेस पे. Now, if you consider a thin spherical shell here, why will it be 0? Whole of the mass will appear to be concentrated at the center. M1 is a sphere of radius r. What is the field on the surface? G M1 by r.
Okay, sir. Got it. Thank you.
M1 is a solid sphere of radius small r. Field on the surface is G M1 by r square. That's what you use.
So, sir, M1 you have taken mass of the sphere inside M1, right? Means M1 के अंदर का small r वाला sphere का mass ना?
एक छोटी सी बात की इतना कंफ्यूजन क्रिएट करते हो आप लोग. एक M1 मास स्फीयर का क्या रॉकेट साइंस है यार? एक सॉलिड स्फीयर के अंदर एक सॉलिड स्फीयर ऑफ रेडियस r has what mass m1.
Yes, sir. Clear.
इतना बड़ा रॉकेट साइंस है, आपको एक बार हॉलो बना दोगे, एक बार सॉलिड बना दोगे, सॉलिड के अंदर फील्ड 0 बना दोगे, एक सॉलिड स्फीयर विजुअलाइज नहीं होता यार आपको उनसे। एक बड़ा सॉलिड m इक्वल टू m1 प्लस m2, अब m1 हॉलो बन जाएगा, हद होगी यार। m1 is solid, m1 is hollow. What nonsense is that? If m1 is hollow, why will I write here m1?
Sorry, sir.
We have calculated field inside the solid sphere. We added the field because of m1 and m2. Solid sphere के अंदर ये hollow कैसा बनेगा मेरी समझ के बाहर है। अब ये बोलना पड़ रहा है, अजीब लग रहा है मुझे। सॉलिड स्फीयर के अंदर m1 इज हॉलो नहीं होगा। एक सॉलिड स्फीयर के अंदर अगर ये लिया तो दिस विल बी सॉलिड। m2 इज दिस मास। क्या बोलूं, कैसा बोलूं, मेरी समझ की बात। I have one more important job to be done. Potential inside a solid sphere. That I will derive tomorrow. And then we will make the remaining part of the class doubtless. Right? Is Shreya there in the class today?
Yes, sir. There are 3 shares.
Whose birthday is it today?
Mine, sir.
Happy birthday.
Thank you, sir. Thanks.
Sir, will you discuss rotational assignment tomorrow?
Tomorrow, I think first I'll have to discuss rotation assignment, then I'll come to S.
Okay, sir.
I have 15 minutes of a job left over with this. I'll finish the potential inside and then I'll come to the rotation assignment. Fine with that? See you people in tomorrow's class.
Yes, sir.
Good day. Bye and thank you.